we are looking at the following sketch, and then they say we are given f of x, and then we're also given g of x. And then they say a and b are the x-intercept of f. So as we can see here, we have a, we have b, which are the x-intercept, and then we know that y here is going to be equal to 0. The graph of f and g, they intersect at b, and then they also intersect here at c. Now they say D, it's a turning point of F. Okay. So now the first thing that we want to do is to determine the coordinates of C. Let's go and check what is C. Now C is a point of intersection between f of x and g of x, but not only that, it is also intersecting with the y-axis. If it intersects with the y-axis, we know something about x in the y-axis. Our x is going to be equal to 0. Now, to get what are going to be the coordinates of C, I can either use f of x or I can use g of x. Now, the simplest between the two of them is g of x. So I will say y is going to be equal to, where I see x, I'm going to put 0 minus 3. And then it will say that the coordinates of C, x is 0, and then our y is going to be equal to minus 3. If you do this, you're going to get minus 3. Now, the next thing that we have to do, they say we should determine the length of AB. Now, for us to determine the length of something, first we need to get the coordinates of A. We also need to get the coordinates of B. So if we're going to get the coordinates of A and B, we know that we are in the x-axis. In the x-axis, what do we know? We know that y is going to be equal to 0. So you're going to have 0, which is going to be equal to x squared minus 2x minus 3. And then you can factorize, guys. You can use brackets, or you can use quadratic. So we have x and x. If I say x multiplied by x is going to give me x squared. I have minus 3. I have plus 1. If I say this one multiplied by this one is going to give me this one. And then when I subtract, they're going to give me minus 2. Then it says you have x, which is going to be minus 1, or you have x, which is going to be equal to 3. Then you will decide which one is A, which one is B. Now, A is on the negative side, so we expect it to be minus 1 is to 0. So you have minus 1 goes in with 0. B is on the positive side, so it's going to be 3 is to 0. Now we're looking for the distance. So the distance of AB is going to be given by, if you use the fact that you are on the x-axis, if you are on the x-axis, then you can add the length of these two things. If you add the length here, you're going to get 4. So you'll say 3 plus 1. Remember, when we're dealing with the length, for those who are doing physics, they will tell you that a length, it's a scalar, meaning that we're only interested in the magnitude. So we'll just add these two. So the length is going to be 4. Or you can use the distance formula if you find this to be a little bit difficult. Okay, we are done with number 2. Now we need to go to number 3. They say determine the coordinates at D. Let's come and check what is happening here at D. They said D is the turning point. Now, how do you determine the turning point? You determine the turning point by using the formula that says x is going to be minus b all over 2a. Now you can come and say, what is A, what is B, what is C? A is 1, B is equal to minus 2, and then our C is going to be minus 3. And then we go and substitute. It says you're going to have minus, open bracket, our A. So we want B first. They say we have minus 2, close bracket, all over. Then we're going to have 2 multiplied by 1. And then if you type this in your calculator, you are going to get negative and negative, it gives you 1. Now, after that, you want to get what is going to be the y value of the turning point. The y value of the turning point, we're going to get it by saying we have f of 1, meaning everywhere we see x, we're going to put 1. Then you have 1 all squared minus 2, 1 minus 3. Now, if you to type this in your calculator, you're going to get 1 all squared minus 2 multiplied by 1, and then you get minus 3. And then it says which we have minus 4. Then the coordinates of the turning point, if they want to know what are going to be the coordinates of D, you'll say D is going to be 1 is to minus 4. And then your answers, guys, should make sense. Let's come and check here. Does it make sense for X to be positive? Yes. Does it make sense for Y to be negative? It definitely makes sense. Okay, the next thing that they say we should do here is to calculate what they call the average gradient of C and D. Now we know what are the coordinates of D here. The coordinates of D, it's 1 is to minus 4. The coordinates of C, we know them. We've already calculated them. We have 0 is to what is to minus 3. Now, if you want to get the average gradient, you get it exactly like your gradient. Nothing has changed. Then you are going to have 4. You have M. Then you just put a bar to say you're talking about an average. So you're going to have y2 minus y1 all over x2 minus x1. Then you're going to say alphabetically, if you do this thing alphabetically, you're going to have minus 4 minus open bracket minus 3 all over 1 minus open bracket 0. And then if you type this in your calculator, you will take out your calculator. Type this in your calculator, you're going to have minus 4 minus open bracket minus 3 close bracket all over 1 minus 0. And then it says your answer is going to be equal to minus 1. So this is going to be your average gradient. Okay, guys, we are on number 5. What are we doing on number 5? On number 5, we want to get what is going to be the angle OCB. So we are talking about this angle here. Let's come and highlight it. Now, from analytical geometry, we already know how to get this here. So for us to get this, we are going to need to get the gradient of this line here. We are going to check which this thing here is between which two lines. So if you check which this thing, the angle that we are looking for is between which two lines, is between the y-axis and is between line BC. So it's between these two lines here. And then remember, we're going to form a triangle with the x-axis. If we form a triangle with an x-axis, this is what we're going to have. We're going to have something that looks like this. And then it should intersect with your x-axis here. So now we're looking for this angle here. Now, one thing that we know about this angle is that when the y-axis intersect with the x-axis, they're going to give us a 90-degree angle here. So that one is fine. The next thing that we want to get now is this angle of inclination here. Before we can get an angle of inclination, we are going to make sure that we calculate the gradient of line BC. So if we say we have M of BC, going to have y2 minus y1 all over x2 minus x1. And then from here, if you do it alphabetically, you're going to have minus 3 minus 0 all over. You're going to have 0 minus 3. And then if you type this in your calculator, it's going to give you 1. Then you're going to use the fact that you have an angle of inclination, which can be calculated as the tan. We'll call this angle here because they didn't say anything theta. So we'll say the tan of theta is going to be equaling to M of BC. And then it says theta is going to be equaling to the tan arc of 1. And then if you say this in your calculator, you'll see, you say shift 10, and then you say 1, it's going to give you 45. Then it says theta is going to be equaling to 45. Now, if theta is going to be equaling to 45, then we can come and put with this one here is going to be 45. But now, if you look at the following two angles here, guys, look at this angle and this angle. This angle and this angle, they are vertically opposite to each other. So meaning if this one is 45, this one here is also going to be what? To be 45. And then we'll come and put with, okay, but now this one here is going to be 45. Now, if they ask us why are we saying which this one here is going to be 45, we'll tell them which is because they are vertically opposite. So that angle there, we'll call it angle OBC. So we'll say angle OBC is equaling to angle theta. Angle OBC is going to be equaling to theta, which is going to be 45, because they are vertically opposite angles. Now, using this triangle here, then guys, you can see which we can get our angle that they are looking for, which is OCB. Then OCB, it's an angle in a triangle. So we can say OCB plus 90 plus 45, they are going to give us 180 degrees because they are sum of angles in a triangle. And then it says that OCB is going to be equaling to 45 degrees. And then we are done with this one then.